Lesson 6-7, we are still continuing to talk about functions. Okay, kind of a theme the second half of the chapter, so we're not going away yet for us. When we talk about functions in this lesson, we're talking about inverses. Okay, I feel like you would have dealt with inverses back in Algebra 1 at some point. By definition, if you look there, inverse, a relation that pairs an element A of its domain to an element B of its range, has an inverse relation that pairs B with A. In short, it flip-flops domains and ranges. Okay, that's what it's trying to say. I know it's a lot wordier than that. The wordy part is, official definition that if a relation has a domain that has an element A, a range with an element B, then the inverse relation switches those and pairs B with A instead of A with B. Okay, so when we talk, anytime we talk inverse, the key about inverse is to get an inverse, you flip-flop domain and range. Which means if I'm saying you flip-flop domain and range, that means you're going to flip-flop X's and Y's. Okay, so for example here, on the left we have an example of a relation. X is 1.2 and Y is 1. X is 2 and Y is 4. X is 0 when Y is negative 8. The inverse. What happens between the inverse? To go from the relation to the inverse, what happened? Instead of 1.2, 1, it's 1, 1.2. Instead of 2, 4, it's now 4, 2. Instead of 0, negative 8, negative 8, 0. Okay, so that's all an inverse is. Inverse notation. Normally with a function we say f of x. For inverse notation it's f inverse of x. So you write f and that little negative 1 to indicate it is the inverse. And that's how you'll give your final answer if you're finding the inverse. Okay, so looking at example A. They give me a function, or a relation, I should say. 0, negative 1, 2, 0, 3, 2, 4, 3. What is the inverse? Just flip-flop, right? If I'm going to write this for the inverse, the easiest thing to do is to set up an XY chart, but instead of writing 0, negative 1, write negative 1, 0. Instead of 2, 0, 0, 2. Instead of 3, 2, 2, 3. Instead of 4, 3, 3, 4. Now, it doesn't say it here, but we're going to talk about it. Are these functions? In the definition, it was defined as a relation. A relation just means a set of ordered pairs. It does not define it as a function. But we need to review what it means to be a function. And we can talk about both, honestly. But are these functions? Do you remember how to figure out if something's a function? Probably been 2 years is my guess at this point. No? What if I say each value in the domain pairs with one and only one value in the range? The shortcut was kind of, do any values in the domain repeat? That was the shortcut. Official wording is each value in the domain pairs with one value in the range. If a value in the domain pairs with two values in the range, it's not a function. So as I look at this, okay, if we look at the original one, does 0 pairs with negative 1? Does 0 pair with anything else? No. Does 2 pairs with 0? Does 2 pair with anything else? No. 3 just pairs with 2. 4 just pairs with 3. Here's the short of it is, were any of the x values repeated or used more than once? No. And so in this case, yes, this is a function. Is the inverse a function as well?
Yeah.
Yeah, because again, none of the x values repeat. So I know, again, it doesn't say it, but it's something we need to prepare for. So I'm going to say function, yes. Each y value pairs with exactly one x value. Okay. So if it pairs with more than one, so if we had the ordered pair 4, 3 and 4, 5, we'd have a problem because the 4 pairs with 2 different y values. B when you're ready for it. There's an ordered pair listed, or list of ordered pairs there. First of all, can you tell me the inverse? What's my inverse?
-5, 0, -4, 1, -3, 2,
Okay. So what did he do? He just took x and y and flip-flopped. -5, 0, -4, 1, -3, 2, -3, 2. I am going to ask the same question again. Are these functions?
No.
Why not? Okay. So the shortcut says, if we're looking at the inverse, because -3 repeated. But what does -3 go to each time? -3 in both cases goes to 2. So that means if I look at a graph, can I tell that there's 2 -3 2's on a graph? No, I can't tell that there's 2 points in the exact same location. Okay, so, you know, it's the trick variation of the problem. This is still a function because, again, each y value was mapped with just one x value, okay? Those x's we didn't have, if we had -3 going with 2 and -3 going with 4, then we'd have reason for concern. Do you see the difference? Okay, so function. And again, you can say the same thing. Each y value pairs with exactly one x value. And if you're concerned about the repeat, the comment you can put in here to help you remind is the repeat pairs the same y value with the same x value. Repeat pairs the same y value with the same x value. Oops. Okay. We've already done C, but I'm going to throw a what if option at you. But C was state whether the inverse of the above tables are functions and how do you know? We've already talked about that, right? We already talked about whether or not they were functions and all that. What if you have the ordered pairs negative 5, 0, negative 4, 1, negative 3, 2, and negative 3, 3. You can't see what I wrote, can you? Is that one a function? Why not? Yeah. Same x values as last time. I just changed one y value. But the difference is now, first of all, negative 3 goes with 2, and then negative 3 pairs with 3. Okay? So there's your example of not a function. So if you want to write a note to yourself, it's not a function. The reasoning, that y value negative 3 is paired with, what is it, 2 and 3. So the x value, negative 3, is paired with 2 unique y values of 2 and 3. Okay, we got the basics there. Given an ordered pairs, you switch x and y, that finds the inverses. Function, you can figure out if it's function based on whether the x values are used more than once. Now, before we turn the page, I think we'll try and talk about one of these. We're going to practice finding the inverse. That's a lot of what this section is all about. And notice there's kind of 4 steps. The graph of f of x and the inverse of f of x will be reflections of each other in the line y equals x. And this is just kind of talking about if we looked graph-wise, that, are you guys familiar with what, can you visualize the line y equals x?
Yeah.
It's identified as the perfect diagonal line. But it'd be the line that goes through 0, 0 and goes up 1 over 1, up 1 over 1, so it goes through 1, 1, 2, 2, all that. So if two functions are inverses, they are reflections across this line. Okay? Now, to actually find our inverses, which is what we're going to do, we switch the variables x and y with one another. So we'll take our x and a y, we'll flip-flop. After we flip-flop, our job is to solve for y. Okay? It makes a note there that for an inverse function to be a function, it must pass the function test, which is what we already talked about, where the x's cannot repeat, or the vertical line test. So if we have a graph, which I think I talked about a little bit, but we don't have any examples here. Do you guys remember vertical line test? If it passes the vertical line test, you draw a vertical line and it will only touch the graph once. If it hits the graph more than once, it fails the vertical line test. Okay? And then when we get done with switching our variables and solving for y, instead of leaving it as y equal, we'll express our answer of, or as, f inverse of x. So just when we get to the end, instead we'll flip out y and say f inverse of x. Let's try one. And then we'll come back to them next week. So let's try A here. A is y equals x squared minus 1. And we want to know the inverse. So what do we have to do? Take x and y and switch them. So when I say switch x and y, instead of writing y equals, I'm going to write x equals. Instead of writing x squared minus 1, I'm going to write y squared minus 1. So that was my first step, is that I switch x and y. After you switch x and y, what did it say to do? We want to take this back to normal function form and solve for y. Okay, because by switching, it's now x equals instead of y equals. So if I'm solving this for y, how do I work to get y by itself here? If it's y squared minus 1, it's minus 1, we're going to add 1. If we add 1 on the right, add 1 on the left. So now, we had x and we add 1, we're now at x plus 1. Are you guys okay if I flip-flop the sides while I'm at it or no? If I go ahead and put x plus 1 on the right, and what remains on the other side? Y squared. And remember, this is my process. I am trying to solve for y if you want the steps. Okay. So it was x equals y squared minus 1. We added 1 over. I now have y squared equals x plus 1. Did I finish solving for y? No. What's that step to get y by itself now? If it's y squared, to undo a square, you square root. If you square root the left, you square root the right. So the square root of y squared is y. Square root of x plus 1? Is that something we know? Yeah. Square root of x plus 1. That's the rule I'm always repeating. When you take a square root in an equation setting, what do we have to put on our answer? What?
Is that equal to 0?
No.
Oh, plus or minus. Yeah.
Plus or minus, right? When you take a square root in an equation setting, which is what we just did, right? We have to put a plus or minus on there to account for both answers. So this is actually going to be y equals plus or minus the square root of x plus 1. Okay? Last step there. Once you get to the end and you have y equals, instead of leaving it as y equals, we want to show that this is an inverse function. So I'm going to replace that y with f inverse of x. So my final inverse function here is f inverse of x equals plus or minus square root of x plus 1. Now, it's not in the notes here, but one of the things you have to be able to do, I think some in homework, is to identify if things are functions. Can you visualize with me the original? What is y equals x squared minus 1? What shape is that? If it's y equals x squared, it's a parabola. And then minus 1 takes it down. Listen to me, please. Now, I think in homework, they ask about whether the inverse is a function. So, this is f inverse equals plus or minus the square root of x plus 1. And the idea when you do the inverse, remember it reflects over the line y equals x. So, if you have an upright parabola, and it's going to reflect over this diagonal line, it's now, instead of being an upright parabola, does it make sense? Can you visualize if I say it's a sideways parabola? I'm kind of running out of time, so I might have to talk about that next week. But here's the deal. This is a sideways parabola. Is that going to be a function? No, because it's going to fail the vertical line test. Okay? So that's an example of something that is not a function. Okay, the inverse is not a function, that is. Okay, homework is out there and available on 6-7. You're welcome to get started on it. We will work with this some more on Monday. do make sure you have 6-6 done.